we are going to discuss about binomial distribution and also geometric distribution. So first of all, we would like to discuss about binomial distribution. Here's the example of the question. Dona sells cookies in her bakery. Every buyer that buys her cookies is required to fill the survey. Based on the survey results, 56% of them rated the cookie as delicious, while the rest of them rated the cookies as too sweet. If a random sample of 20 buyers is chosen, find the first one, the probability that there are at least 15 buyers rating the cookies as delicious. The second one, the probability that the number of buyers rated the cookies as delicious is less than or equal to 5. The next one, the probability that buyers rated the cookies as good is at most 3. And then the last one, on another occasion, a random sample of n buyers of the cookies is chosen. Find the smallest value of n for which the probability that at least 1% rated the cookies as delicious is greater than 0.997. Now we go to the first problem. The probability that there are at least 15 buyers rated the cookies as delicious. What does it mean by at least 15 buyers? At least 15 buyers means we need to find the values of the probabilities from px equals to 15 until px equals to 20. And then after we got all the values, we just sum them up together to get the final result. The first one, px equals to 15, is equals to 20 combination 15 times 0.56 to the power of 15 times 0.44 to the power of 5. Now, what is 20? 20 is the total number of the buyers from the sample. And then 15 is the total number of people that rated these cookies as delicious. And then 0.56, where do we got 0.56? So previously, as you can see in the question, it said that there are 56% of the buyers rated the cookies as delicious. And then if we convert it into decimals, we just get 0.56 to the power of 15, and then times 0.44 to the power of 5. Now, where do we got 0.44? We got 0.44 because, as you know, that the sum of all probabilities, all kinds of probabilities, should be 1. So that's why we just do it like this. 1 minus 0.56 equals to 0.44. So that we got 0.44 to the power of 5. Why is it to the power of 5? Because the total of all the powers should be 20. So if we already got 15 here, so we just put it 5 here. So that's why we got this value 0.0427. And then we do the same thing to the rest of the probabilities. And then after we got all the values, we just sum them up together, and then we get this final result, which is 0.0660. So the probability that there are at least 15 buyers rating the cookies as delicious is only 0.0660. Now we go to the second question. The probability that the number of buyers rated the cookies as delicious is less than or equal to 5. Basically, it's just the same as previously. Now, what does it mean by less than or equal to 5? Less than or equal to 5 is actually, you need just to find the px equals to 0 until px equals to 5 and then sum them up together. So, it's just simply by doing this, px equals to 0 equals to 20 combination 0 times 0.56 to the power of 0 times 0.44 to the power of 20, and then we got 7.4 times 10 to the power of minus 8. And then we do the same exactly thing until the rest, until px equals to 5. And after that, we just sum them up together, and then we get this value 4.97 times 10 to the power of minus 3. So, in conclusion, the probability that the number of buyers rated the cookies as delicious is less than or equal to 5 is only 4.97 times 10 to the power of minus 3. So, the next one. This question is actually similar with the previous one. It's just different wordings. So the probability that buyers rated the cookies as good is at most 3. What does it mean by at most 3? It's actually just the same as px is less than or equals to 3. So we just need to find the values of px equals to 0, px equals to 1, equals to 2 until px equals to 3. After we got all the values, we just sum them up together and then we get the final results. So as you can see, the methods, the ways, the calculations, and then the final result is only 1.99 times 10 to the power of minus 4. Now we go to the last question, which is actually this is a bit challenging. On another occasion, a random sample of n buyers of the cookies is chosen. Find the smallest value of n for which the probability that at least 1% rated the cookies as delicious is greater than 0.997. If in the previous question we already know the number of total buyers that from the sample, which is 20, in this question, we don't know yet the number of the buyers. We only know the probability, which is 0.997. So, uh, to solve this question, we can use the concept of logarithm. So, it's just simply by logarithm 0.56, which is only the probability that the buyers will rate these cookies as delicious, times 3 times 10 to the power of minus 3. Now, what is 3 times 10 to the power of minus 3? 3 times, we got 3 times 10 to the power of minus 3 from 1 minus 0.997. And then we just put the value here, and then put these values in your calculator, and then we will get this value, which is 10. So in conclusion, the smallest value of n for which the probability that at least 1% rated the cookies as delicious is 10. So we've done with binomial distribution. Now we go to the second topic, which is geometric distribution.
And now I'm going to explain to you guys about geometric distribution with an example question. In a certain bakery, 30% of the buyer buy red velvet cakes, 12% of the buyer buy brownies, and the rest buys cookies. There are n buyers at the shop. Find the probability that the fifth buyer is the first one to buy the red velvet cake. Find the smallest value of n which there is a chance of 99% or more that there will be a red velvet buyer at least once. There. The probability that fifth buyer is the first one to buy the red velvet cake. That means 4 buyer before him buys anything but red velvet cake. We can use the formula of geometric distribution right here. Px equals to r 1 minus p to the power of r minus 1 times p, which means we need to find y 1 minus p first. The p here is the probability of buyer by red velvet cake, which is 30%. In decimal place, it comes to 0.3. And 1 minus p means 1 minus 0.3. We can use this kind of hard way or easily as 1 minus 0.3, which is 0.7. To the power of r minus 1. R here means the buyer. There are 5 buyers, so 5 minus 1 is 4. You can write 4 here. 0.3 to the and times p. P is 0.3, so we can simply write p 0.3 to the power of 1. To the power of 1 means times 1, or yeah, only 1 of 0.3. So in your calculator, you can come with this answer. Next question. This one is a bit tricky. The smallest value of n for which there is a chance of 99% of 99% or more that there will be a red velvet buyer at least once. So it means that there will be how many buyers till there is the percentage of 99% that they buy red velvet cake. So we need to find it as we can find it like this. The conventional way, which is px equals to 1 plus px equals to 2, px equals to 3 until blah 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 plus px equals to n. Px equals to n is the furthest one is yes. So px equals to 1. We can simply write it as 0.3. Px equals to 2, 0.7 times 0.3. And px equals to 3 is 0.7 to the power of 2 times 0.3 plus blah 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 until 0.7 to the power of n times 0.3 is the value of 0.99. So we can use the Sn, summation of n. Summation of n, the Sn will be 0.99. A here is the first value of the geometric sequence. Right here we can see it as a geometric sequence. A, so we can write the first value of geometric sequence here, 0.3. In a bracket, 1 minus 1 minus r to the power of n. R is the other value, or r is 0.7 right here. So you put 0.7 right here to the power of n. N is what we are finding for. Divided by 1 minus r. 1 minus r, we can write it as 1 minus 0.7 because 0.7 is r. So we can write it like this. 0.99 equals 1. 1 minus 0.7 is 0.3. So we can cross it out. 0.3 and 0.3. So we come up with this 0.99 equals 1 minus 0.7 to the power of n. So I can move the 0.7 to the left and 0.99 to the right equals to 0.01 equals 0.7 to the power of n. And the formula of logarithm is a to the power of n equals to b, and in logarithm to find n, we can find n equals log ab. Here, the a here is 0.01, so we can write 0.001. And the n here is what we are finding, log a. A here, if we can see like in the equation, a to the power of n, so a is 0.7, we can write 0.7 here. B is the the equivalent value, which is 0.01. So log 0.7 times 0.01, n equals to 12.9. We cannot conclude there is 12.9 buyers because we cannot write people as this in decimal places. So we can round it up as 13 buyers. I think that's all from me and Dona. Thank you.